An environment in which great scientific as well as technological advances are being present is in the area of robotics, which is an important pillar in mechatronics. Although this beautiful area deals with the analysis, construction, design, and control of certain systems, mechanics would help to move within a system or remove objects according to their purpose. Although in development of robotics, there is a wide variety of interests and technologies that different companies are developing, although it is difficult to classify robots with our sequences of discoveries on which one can rely. However, one can clarify the line in which robots have a specific purpose and in this way see the progress they can carry out. In addition, one must always bear in mind that new and optimized technologies adapted to this environment emerge every day. Mobile robots are usually designed to move through environments where there are different obstacles since they are always in motion. Therefore, the environment of the robots change in this way. They must constantly reorganize the environment where they move in order to adapt adequately. To begin to delve into this beautiful field, one must bear in mind that robots exist endless area to study, but usually where they cast further investigation is in the kinematic model, the dynamic model, the control microcontrollers, algorithms, planning, recognition of the environment, among many others. Finally, the applications that we can visualize in our environment are a huge variety of fields from mining to observation of basins or underground tunnels where access to human being is difficult to the least unimaginable, and is in our human body where usually there is always an exponential advance in the area of medicine where little by little it has been needing the area of control engineering. Leaving one side to this there are also the famous space flicks where robots are taken to explore new lines to conquer, such in this case of Mars One, its participation in surveillance of rebirth of terrain in the military field is also very notable, as there is a good application in the maritime area among many other disciplines. To begin the analysis, we carry out the corresponding simulation within CLAF in terms of its angular movement and its movement with respect to the axis x and y and the angle phi. Signets were the variables necessary to make the block diagram work as contained, and inside of this x-cos are the block diagrams for the angular velocity motion and the motion in the axis x and y and the angle phi, where double J is the angular velocity of the right wheel and double L the angular velocity of the left wheel. Movement in the x and y axis and the angle phi. Okay, in this part, uh, in the moment in the x and y axis and the angle phi, we can see in this figure that the line in red represents the xy and the line in green represents the x, and the angle phi is represented by the line in black. The last mentioned lines remain constant, while the line indicates to negative infinity. In modeling of angular velocities. Okay, as we can see, the angular velocity of the left wheel is different from the angular velocity of the right wheel. Therefore, the graph looks like an ellipse. If both angular velocities were equal, the moment generated will be that straight line. For the dynamic model, okay, you can see side notes where the variables are contained in order to perform the dynamic model. Block diagram to be able to linearize in dynamic model of mobile robot. And next, that are the graphs resulting from alpha point, and velocity. Next is the design in SolidWorks. Okay. We represent the mobile robot model in a system design program that we learned to use previously, and that program is SolidWorks. Below, the process that was carried out will be displayed. In order to simulate our dynamic system, we rely on the following models. Okay, one of the models is the mobile robot model taken from Canudas, and the other model is mobile robot that was assembled in advance for school purpose. Okay, in consideration of both designs, an attempt was made to do a synergy simulation in SolidWorks, and the results obtained will be shown in short time. Okay, you can see a render image of the mobile robots composed of two parallel wheels and a rear wheel. Okay, that's the finally result. And all the equations and functions on which we rely for the dynamic analysis of the mobile robot can be found in that document. That's a mobile robot in presence of the 1981 IAAA International Conference on Robotics and Automation, Sacramento, California, April 1991, in Section 2, the Dynamic Model. That's a very interesting article, and this project is based on that article. In specific, in this part of the dynamic model, of the simulations and diagram blocks are obtained of that part. For example, all the variables that the team used, we obtain of this part. The experimental evaluation, and that's all. And that's are the conclusions for the simulations. And like in this part say, the simulation results have shown improvements under inverted situations, while in good taking part capabilities no show. Here to like space, their tests have also been tested experiment in the micro WMR kitboard with positive remake model are path and mislead and recovering during sample motions. Well, that's all. Thanks.